Students, today I'm going to start basic chemistry for you. Especially I brought this for the regular students who want to learn about the measurements, calculations, what are the units, what are the symbol of the units. Large number of things I have brought for you. So first part of the topic is measurement and calculation are concerned with the quantities. The quantities are length, velocity, volume, mass, energy, etc. Before going to measure the quantities, first of all, you must know what do you understand or what do you mean by the word SI. SI unit. Everybody knows about the SI unit. What is that SI unit? It is a international system, or you can say system international. It is a system international. SI. It is a French word. There are 7 base units. Those units are meter, kilogram, second, ampere, Kelvin, candela, and mole. The 7 base units are meter, kilogram, second, ampere, Kelvin, candela, and mole. So these things you must know actually. Measurement and calculations are related with the length. Quantities like length, velocity, volume, mass, and energy. Then the units are meter, kilogram, second, ampere, Kelvin, candela, and mole. Now see the 7 SI base units. The physical quantity, when we have to measure the length, we have to measure it in what unit? It is meter, and symbol given for that unit is M. The another physical quantity is mass, measured in kilogram, and the symbol is kg. Time, name of the unit is second, that is second. You can write S or SEC, second. Temperature is measured in degrees Celsius or it is measured in the Kelvin. Light intensity is measured in candela and denoted by CD. Amount of substance is measured, or the name of the unit is mole, that is MOL. These are the 7 SI, that is System International Base Units. Length is measured in meter, mass is kilogram, time in seconds, electric current in ampere, light intensity in candela, and amount of substance in the mole. The another part I brought for you is this is actually what I have tried to write the it means some quantity, some measurement, some calculation at a glance. If you will revise this, you know all these things, but only this is a revision of the measurement and calculations. So second part is the decimal fraction and multiples for the units. So decimal fraction is if 10 raised to the power minus 1. It means that it is deci, denoted by small d. When it is 10 raised to the power plus 1, it is deca and the symbol is dA. 10 raised to the power minus 2, centi, symbol is C. 10 raised to the power plus 2, minus 2 is centi, plus 2 is hecto, plus 2 is hecto, given by small h. 10 to the power minus 3 is milli, given by small m. 10 to the power plus 3 is kilo, given by k. 10 to the power minus 9 minus 6, 10 to the power minus 6 is micro, given by mu, whereas 10 to the power 6 given by mega, small, that is capital M. 10 raised to the power minus 9, that is nano, small n. 10 raised to the power 9, giga, and given by capital G. 10 raised to the power minus 12, that is pico, that is denoted by P. 10 raised to the power 12 is tera, capital T, denoted by capital T. 10 raised to the power minus 15 is called femto and denoted by small f. 10 raised to the power plus 15 is peta, denoted by capital P. 10 raised to the power minus 18 is called atto, small a. 10 raised to the power 18 plus 18 is exa and it is denoted by capital E. I know that students know this, but this I am trying to make a fast revision for you. If it is 10 raised to the power minus 9, it is deci, plus 1, 10 raised to the power minus 1 is deci, plus 1 is deca. Minus 2 is centi, plus 2 is hecto. Minus 3 is milli, plus 3 is kilo. Minus 6 is micro, plus 6 is mega. Minus 9 is nano, plus 9 is giga. Minus 12 is pico, plus 12 is tera. Minus 15 is femto, plus 15 is peta. Minus 18 is atto, plus 18 is exa. And you must remember the units and the symbols. So the second part, what I have brought for you is derived units. Physical quantity is force, unit is Newton, given by capital N. Pressure, Pascal, PA. Energy, work and heat, joule, capital, that is joule, it is denoted by small g. Power, that is watt, it is watt and given by W, capital W. Electric charge is calculated or it is measured in coulombs, that is C. Symbol is C. Potential difference is measured in coulombs and given by the C. Potential difference, it is the electric charge is measured in coulombs given by C. Potential difference is measured in volt given by the small v. Electrical resistance is measured in ohm, that is given by omega. Physical quantity like electric conductance is measured in Siemens given by small s, and frequency is measured in hertz, that is Hz, capital H, capital Z. Some another units are area. Name of the unit is square meter. Definition of the unit, it is m square, that is called square meter. Volume is measured in cubic meter, m raised to the power 3, it is cubic meter. Density is measured in kilogram per cubic meter. So, kilogram raised to the power minus 3, it is called per cubic meter. Concentration, mole per cubic meter. Mole per cubic meter. It is mole m raised to the power minus 3, that is per cubic meter. Velocity is meter per second, that is meter second inverse, that is meter per second. Surface tension is measured in Newton meter, that is Nm minus 1, that is raised to the power minus 1, that is Newton per meter. Viscosity is measured in kilogram per meter per second. So these are very important things which we forgot because of the less revision to the subject. Last thing, that is some important conversions. Length, SI unit, in SI unit it is, if it is 1 meter in CGS system, it is 100 centimeter. Mass, 1 kilogram is equal to 1000 gram. Force, 1 Newton is equal to 10 to the power 5 dynes. Volume, 1 meter cube is equal to 10 to the power 6 centimeter cube. Pressure, 1 Newton per meter per square meter per square meter is equal to 10 raised to the, that is 10 dynes centimeter inverse. Work is calculated or it is measured in joules. If it is 1 joule, it is equal to 10 raised to the power 7 ergs. This is the general awareness about the conversions. So thank you students, and try to revise for your discussions.